All right, this is long overdue, so let's get into it. Local AI Part 2. So we're going to be talking about how to choose a local AI. And I really recommend that you start doing this because as we get more and more expensive with the cloud LLMs, you're going to have ways to reduce the amount you're spending, but you still want to increase your productivity. And as I mentioned in the previous video, the way you're going to do that is you're going to do the grunt work on your local machine and then take that finished product, run it over as your first draft to your ChatGPT or Claude or LLM of choice, and then you'll bring it back and make fine-tuned touches and then send it back over there and then make the perfect version. This is going to save you so much money, and you won't have that annoying, you have to wait 5 hours until your subscription resets or you've got to upgrade to a bigger plan. You won't have to deal with that. So let's get into how you choose one. First of all, when you are looking at the whole LLM thing and bringing it home, or what we call running local LLM, it's going to get confusing real quick. You're going to look at the names of all the different models and you're going to say, what do I use? And you're going to see a 7B, a 70B, a 235B, and you're going to be like, I don't know what the heck this is. Here's what it actually means. When they talk about B, they're talking about billions of parameters. A parameter is like a little tiny dial the model learned to turn during training. So you see down here, you have a regular volume knob. Here you have one with a lot more numbers on it. And the more numbers or settings you have, the more fine-tuned it is. And here you have another one that's even got even more, so it's more fine-tuned. So when you have a 7B parameter model, it's a smaller dial with less options. When you have a 70B, you're going to have more. And when you have a 200, or they've even got a trillion now, you got so many little tiny increments that you can use to fine tune the model. Now, obviously, the more parameters, the bigger the brain, meaning the more capability the model has. So usually when we say it's a better model or it's got a bigger brain, it means that it's got better reasoning, better knowledge, because you can get more little increments in there, making it even more fine-tuned. But it's also going to be slower and pricier, and it's going to require more VRAM. When you are using ChatGPT or Claude, it is not a simple computer. It is a program that runs on hundreds, if not hundreds of thousands of graphics cards, all stacked together in a data center, all of them running at very, very high speed, very, very high power. Well, nobody's going to have that in their closet. So you need something that's smaller. And because it's smaller, it's going to have less choices. And so it's not going to be as powerful, but it can still get the grunt work done. The other thing you have to remember about this is if you're not going for a general thing, meaning you need something that's a brainiac on everything, you don't necessarily need a great big huge model. You need something that's a little more fine-tuned and a little more specific. And that's how AI is changing. Rather than using gigantic, powerful models that cost money, people are using smaller models that are fine-tuned and focused specifically on the area they need. And then if they need to make it bigger or badder, then they turn it over to the bigger model. So that's essentially what we're doing here. Okay. Next, what size should you pick? Well, a 3 to 7 billion parameter model is a lightweight helper. It's fast, it's cheap, it's great for straightforward chat, extracting information, and simple code help. An 8 to 14B is the sweet spot. This is what you want to use for local use. If you've got a 16 gigabyte graphics card, this is going to give you better reasoning and writing, solid coding assistance, GPU friendly. You'll be able to spell check, come up with ideas, do very, very basic stuff. It's not going to write volumes for you. It's not going to do high level scientific. Remember, you're dealing with something that basically does grunt work. Next, 30 to 40B. If you've got, like I do, an RTX 3090, or you've got a 4090, a 5090, and there's going to be others coming down the line, and you're rocking 18 to 36 gigabytes of VRAM on your graphics card, you're going to get better reasoning, better reliability, and it's going to give you ability to code. And you're going to be able to not necessarily code everything, but it's going to allow you to do the basic coding structure that you can then hand off to Opus, which is the best coder right now, and it's going to do wonderful things for you. 60 to 70B, 65 to 70B it can do heavy tasks. It's not going to be ChatGPT. It'll be roundabout maybe ChatGPT 2 or 3. It's good, especially if you're using a mixture of experts models, and we're going to talk about that later. But you're going to need probably around 48 gigabytes of VRAM, which means you're going to have two 3090s, two 4090s, two 5090s stacked together. Now, graphics cards are very expensive and very hard to get, but by next year, they're going to be coming out with newer models, cheaper models. You may also be hearing about the Macs and the Mac Minis and other computers that are coming out that share both regular RAM and video RAM. Those are going to be a real bargain coming up in the next year. So learning how to use these and experimenting with them, even on a small graphics card on a small computer, is going to work for you, because later on, everybody's going to have their home-based version of a chat model. So get in early. All right, speed reality check. Smaller models are many, many times faster. They're not as smarter, they're not as beefier as the ones you use that you pay $20 a month for, but they are very, very fast. The bigger the model you get, the slower it's going to slow down, because it has to use more of the card. It takes a little bit longer, and we'll talk about speed in later episodes. All right. When we talk about base models, or the different types of models, you're going to see 75B base, 75B instruct. What do those words mean? Well, think of a base as a very smart person who's read the entire internet, and instruct as that same person after finishing a how to follow directions boot camp. So the base is trained, to predict the next word. It's the foundation model. It's the big, huge model that they've trained, the very first one that has everything in it. It's a great starting point for fine-tuning into a niche. So if you were to take ChatGPT, which is a gigantic general model that knows everything about everything, and you were to narrow it down so that it focused on something like medical, legal, maybe even your brand, that's when you start getting away from the base foundation model into instruct models and other types of models. Then you have raw. It doesn't follow the instructions cleanly. Raw is the very first version they made before they went in and said, no, you can't say that. You have to say it this way. This is what this means. It hasn't been trained at all. They just took and gave it all the information. It's stored in its brain, and you ask it questions, it might say anything given everything that it's been trained on. So raw is kind of crazy. Base is a little bit more refined, and then you start getting into smaller versions that have been trained properly, like instruct. Think of it like when you're training a dog. You can train a dog to sit, but to have it sit, then lay down and stretch out, or then get up and eat on command. Each time you train it to do something a little bit more specific, you're instructing it. But when you first bring the dog in and you go eat, well, it will eat, but it's a long way from eat to sit, roll over, play dead. Training. Okay. Instruct chat. After you get base, you get instruct. Instruct is the base model after it has been fine-tuned. And we'll talk about RLHF later, but after it's been fine-tuned in one of these methods, it follows instructions and it will stay on task. And it tends to be safer because it's got those guardrails in there, and it won't go crazy and start telling you crazy things like, I'm Mega Hitler, like Grok did. And it's the best default for when you're doing question and answer, brainstorming, you need help coding, you need it to do specific tasks. Choose the model that says instruct, not the base model. The base model is usually the biggest, baddest, untrained, out of control model. If you don't know what you're doing and you're not planning to do your own fine tuning, then you want to go for the instruct. And even though it's been instructed, you can still fine tune it down till it's even more, better for what you're using it specifically for. So usually you want the Instruct unless you're going to do the fine tuning. Now then we've got domain specialized variants of models. You're going to see models that say coder. It means that model has been trained specifically to code. So it's better at debugging, meaning cleaning up code and finding the mistakes. It's better at tool use, meaning if it needs to use other types of apps or agents, as we call it, it knows how to use them. And it's going to give you editor style answers, meaning it's going to double check and be fine tuned to know how to double check things to make sure they're correct. There's also math and reasoning models. So if you're doing step-by-step logic, you're doing math problems or geometry or construction or those kinds of things, you're going to want the math reasoning type models for your specific job. If it's multimodal, multimodal means it doesn't just read text, it reads pictures, it reads sound, it reads PDFs, all these different things that you want to use, audio and video, to give it when you're giving instructions. You want multimodal. So if you're going to organize pictures or you want something where you're going to be working with both video and audio, choose a multimodal model. Next is embeddings. Now, embeddings are not a chat model. They're used to convert text into vectors. Now, what this means is we're used to something like ChatGPT. It's in the name. Those models are huge and specifically designed to be able to have conversations with human beings. If you take out most of that dialogue and grammar and stuff that you need to chat with human beings, you're going to end up with a smaller model, and that model is going to be focused on something like converting text into vectors or vectors into graphs. It's not going to have a conversation with you, but it will get the job done. So if you don't like command line, meaning typing in code and stuff like that, you would rather have what we call GUI, graphic user interface, like Windows, where you can interact with it or chat with it like ChatGPT, you're going to stay away from embeddings. All right, search and RAG. These are things that are smaller, faster, and cheap. The output is in numbers. It's not going to be in paragraph. So if you're not a quantitative person who's into coding and all of that, you're probably going to have a bigger, more powerful model because it's going to have to incorporate chat unless you really know what you're doing with numbers. All right, formats and quantization. You're going to see in the back of models, if you go over to Modelscape or you go to GitHub, or you go to Hugging Face, which is the best place, I think, if you're going to pick up models, you're going to see GGUF popping up behind those models. What that means is someone, usually not the company that created the model, has taken that model, maybe the base, maybe an Instruct version, and they have so fined it down, and they have also made it smaller and smaller and smaller using software methods so that it will fit and run on a smaller computer. So when you see something that says it's been quantized, as I mentioned in the last video, it just means they've used mathematical software to make the model smaller so that it will fit on your video card instead of having to have, a data center filled with video cards. Okay, GGUF is a compact format used by Llama. Llama is a model, and it's a series or family of models that are open source, meaning they are free. And a lot of these models that you're going to see, even those from China, are made using Llama, or at least work with Llama. Okay. You're going to see words like safe tensors or PyTorch. These are full precision checkpoints. What this means is they are great, big, huge coding files that are used to make the entire model smaller, more compact, and more fine-tuned for your usage. Now, if you really want to be a hotshot in AI, you can learn PyTorch, and you can learn how to create safe tensors. But basically, safe tensors and PyTorch are the things that you use with your model that fine-tune it and make sure that it's doing what you need it to do and staying within the guardrails. GPTQ, AWQ, EXL, these are just other flavors or quantization. They are just other ways that are used to make the model smaller, cleaner, and easier to use. They shrink the memory without ruining the quality, or at least without ruining it too much. Why it matters? Quantization is how you fit big models on smaller GPUs with small accuracy trade-offs. For local use, a 7 to 14 billion parameter in 4-bit often hits the best balance of quality versus speed versus VRAM. When you see 7 to 14B, you know that's 7 to 14 billion parameters, the dial analogy we used earlier. And 4-bit means how many times it has been shrunk down compared to the overall. So if you've got a 7 to 14 billion parameter model and it's been shrunk down using 4-bit, it's going to fit on probably an 8 to 16 gigabyte video RAM card. These are important to know because if the model you choose won't fit on your GPU, you're not going to get results. Okay, tokens. We talk a lot about tokens, and I'll say this again and again. A token is a part of a word, almost like a syllable. So when we're talking tokens, whether they're charging you for tokens, whether they're saying the amount of information you can be put in or you can put into your question or prompt is tokens, we're talking about 3/4 of a word in English is a token. So if it says 40,000 tokens, you're looking at each of those tokens being 3/4 of a word. So you can do the math and figure out how many words you can actually put in a particular prompt or that it will give you back or how fast. Even speed is given in tokens. If it's giving out 4 tokens per second, it means it's giving out probably a word and a quarter a second. So you can see how long that would take for it to spit out an answer. Okay, bigger context. When they talk about the context of a model, what they're talking about is how much information you can put in your prompt. The prompts that are coming out now for a lot of the Chinese models can take 100,000 tokens, which means you can put 100,000 3/4 of a word in your prompt. So if you want to say, give me the summary of this book, and the book is 400 pages, well, 400 pages is probably going to well exceed 100,000 tokens. So you have to decide how much information you need to put in or put it in a piece at a time to get the results you're looking for. When they talk about KV cache is the amount of memory that needs to be left for the computer to do its calculations in addition to the prompt information. You know, if you're filling your tank with gas, there's got to be some room in there to have, if you fill it all the way to the top, if you cap it out, there might be a better way to explain that. You have to have some wiggle room, right? If you have to have, for example, if I'm building a server and I want my server to have 32 gigabytes of memory, I also have to have a little bit of memory in the background for it to run Windows and the other processes. So if I want 32 gigabytes of memory, I'm actually going to have to put in more like 38 so that I have 6 gigabytes of memory that runs all the background systems, and then I have the actual 32 I can use. Same thing here. That KV cache is the extra it needs to be able to calculate or do the things that you want it to do, in addition to all of the instructions you're feeding it. All right, for practical tips. For long documents, like a 400 book thing, you're going to use a RAG instead of just dumping everything into one prompt. And later on, we'll get specifically into how to build RAGs specifically so that you can feed your LLM huge amounts of information. And not only that, you can increase its memory so it will remember what you've talked about later, and you don't have to start over with each and every prompt or each and every project. All right, dense versus MOE, mixture of exports. Here's the thing. For the longest time, we were using dense, which means when I asked a question, it went out and it looked at all of the information it had been trained on. Now, if you can imagine something like ChatGPT 5 that's been trained on so much information, it's going out there and checking all of that. It burns a lot of resources, it costs a lot of tokens, it takes a lot of time, and more importantly, you have to have a really big model to do it that way. Now they're using mixture of experts, which basically means if you consider your LLM as a room full of professors. When you're using a mixture of expert models and you ask a question about literature, it only goes to the literature professor. It doesn't hang out with the math professor. It doesn't hang out with the geography professor. It goes specifically to the professors that are professionals or experts in the area you're looking at. By doing that, it is faster, it takes up less resources, and though you might have a mega billion-dollar model, it only accesses the small part that is associated to the area in which you're doing your prompt or your request. And so it allows it to run faster and lower active compute. So you can have a huge model, but because you're not using all of it at once, you're able to use it in a much smaller local form factor. Makes it easier. All right, why size and type matter? And yes, size does matter. Quality versus cost. Bigger models usually write better, reason deeper, and hallucinate less, but they're very, very slow and they're very, very expensive to host. You may not have heard this, but they are actually losing money on AI. They're giving it away for pennies on the dollars to get everybody addicted to it. And then the true prices of what AI costs are going to come out. So you're going to see a lot of the use of ChatGPT. It's already happening. It's happening with Claude, where you're going to get less time, less tokens, and it's going to get more expensive because these huge models take up a lot of power and a lot of energy. So they're willing right now to lose that money to get you addicted, but it's going to come back later as they're going to charge you more. That's why it's so important to have this going. Follow through. Instruct models. Remember, not the base. The base is the great big huge one. Instruct models follow direction and stay on rails. Base metals are for builders who will fine tune. So, you know, when you get a Toyota car or any kind of car, you usually get the consumer model. It's already got seats in it, seat belts, all the good stuff. But when they first make it, when they make the prototype, it doesn't have the seat belts and the burled wood. It's a big, huge engine. The big, huge engine, the prototype, that would be the base model. You want the Instruct. It's been a little bit more fine-tuned and more for consumer use. Hardware fit. If you're using GGUF models, it's people who have taken that same car and they've taken aftermarket products, so to speak, and they've made it even more comfortable for you. So it's going to be better use. It's going to be easier to use, and it's going to be more directed specifically for your brand or whatever it is you do. You can take big models that have been quantized, shrunk down, and run them on your local system. Will they be as big and huge and powerful as the base? No. Will they be big and as pretty as the Instruct? Probably not. But they will be able to get the job done enough for you to use them to do the grunt work, and then go over to the big expensive models and have them fine tune it or make it better, and then you've got a better product. And you've had more control, more security, and most importantly, it's been cheaper. Throughput. If you need to do many requests, then you need to pick a smaller or MOE model, meaning that if you're going to be using this a lot and running a lot of requests and doing a lot of stuff, you need to get a smaller model. Okay. If you need a single shot best model, or you want to, build this for me completely now, well, you're going to have to go bigger. If you want to do it in pieces, you can go local and you're going to go smaller, which I think most people are going to have to do because they can't afford what the prices on AI are going to be very soon anyway. 2 rules of thumb. Start small, step up only if you must. A well-tuned 7 to 14 billion parameter model, which should fit on a 16 gigabyte card, it'll run and you'll be able to do some simple stuff. And that's basically all you need. I mean, think of it this way. If you're using Microsoft Word, you're only using a tiny, tiny bit of that. If you're going to be a Microsoft Word Pro user, well, you're going to need to learn it and you're going to need to get much bigger hardware. Not really, but you're going to really have to know what you're doing. But most people don't. So most people can get by with a 7 to 14 billion parameter. It'll do most of what you need to do. And if you do have to go a little bit bigger, look for a GGUF model, that's quantized. It might be a little slower. It might not have all the bells and whistles, but it'll get what you need to get done the way you need it done. And then you can put the polish on it in a cloud-based version like ChatGPT. All right, next time we're going to look specifically at the different video cards I would suggest and experts suggest that you use if you're going to use a local model. This is Keith. Have a fantastic day.